Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'll be one of your hosts this evening, Dr. Elena Hyde, and I'm joined tonight by Professor um, sorry, Mary Helen Armour, who's here again as a returning special guest. We are broadcasting live from the Allan Carswell Observatory, located in York University in Toronto, Ontario, Canada. This is a special York Universe broadcast direct onto YouTube, as opposed to astronomy.fm, which has unfortunately stopped broadcasting for the moment. The York Universe production works in concert with our online public viewing. If you're on YouTube, you probably already know that because this YouTube is the online public viewing run by our observatory team, which runs from the same hours from 9 to 10 p.m. local Toronto time. If you ever want to find old episodes or just follow the links over to OPV, you can always go to our website, yorku.ca/science/observatory, and click on any link that says YouTube or go over to online public viewing. We always do these every Monday night from 9 to 10 p.m. Local Toronto time, unless, of course, it's a holiday. If you have any suggestions or for future topics, or just want to send us an email, you can always email observe@yorku.ca, and you can connect with us on Twitter at York Universe and York Observatory, Instagram, York U Observatory, and Facebook at Allan and Carswell Obs, just to be a little different. All of our programs are free, but if you'd like to make a donation, you can see that same website I mentioned before, yorku.ca/science/observatory. We are monitoring the chat room. Our crew is live on YouTube right now, waiting to get questions from you all and showing lovely stock images at the moment because it is, in fact, very, very cloudy here in Toronto tonight. The clouds keep rolling in. So I'm very happy once again to be able to welcome back Professor Mary Helen Armour. If you missed her last episode, she is a special guest speaker, a professor and faculty at York University. She teaches a number of science courses in the natural science division, and her background is both in astronomy and earth sciences. And we actually had her recently as an astronomer in residence out at the Killarney Provincial Park just this last summer. That was back in July, if I'm remembering correctly.
That was
And July 20 something, as I recall, Mary.
yeah, it was right into the first day or two of August, and it wasn't the greatest weather, but we did have one really nice observing night right when the Perseids were getting going. So we
Yeah,
had
those good nights make it all worthwhile.
oh yeah.
And of course, we had you talking about, I believe, lots of asteroid impacts and things last time because of your geology expertise. So we'll probably do a little bit of the same this time as well. We have all kinds of fun things lined up for tonight. I don't imagine that you're having any better luck with the clouds tonight than we are at the York University campus.
No, it was nice and clear today, and I was thinking, oh, we'll see some good stars, but I was out about 45 minutes or an hour ago, and it had all clouded over here too. So
Yeah, I think it's the big temperature flips usually tends to bring the clouds in, and we are looking at a bit of a temperature flip for tomorrow, I believe. Something like a 10-12 degree jump, and it is solid clouds as far as I can see on the radar.
yeah, it's like I said last night or yesterday or whatever was nice because it got cool, so it was very clear.
Yes,
Early
yes,
in the
and
morning, we're up. It was quite spectacular, but yeah.
well, we had some very dedicated observers last night. We were able to do 3 completely separate observing runs all the way until about, I think, 2:30 in the morning.
Oh yeah.
And at which point we had to stop because we were too tired. But it was very, very successful running. Of course, we did, little spoiler for anyone who hasn't heard the announcement yet, but the Allan Carswell Observatory has recently been heavily renovated with brand new domes that are robotic and controllable, and we've just finished the rest of the interior renovations, the flooring and the painting. So it's been quite nice to have them both actually working all night and running around on the sky. If you do get a chance to join on one of our public observing nights, those are now every Wednesday. So make sure to check that website I mentioned during the intro if you'd like to get a free ticket. All right, so let's go ahead and launch our show for tonight. We've got a few fun things planned. Per usual, I think I'll go ahead and start off with a little bit of this week in space and astronomy history, just for fun. Go back in time a little bit to see what else was happening in October, and I actually found two for tomorrow. So this is the 23rd. I've got 24th of October. So if I go back to 1946, which is either very close or very, very far away, depending on how you look at it. 24th of October, 1946. This was actually the first photograph of Earth from outer space. And if you've ever taken a history class or an astronomy class, they show you that dateline of thousands of years of human history and going back to ancient Egypt and beyond, and how many thousands of years was that ago? Was that 1,000, 2,000, 5,000, 10,000? And of course, we have human records of various sorts of star charts and things like that in Australia, going back to almost 50,000 years. And it wasn't until 1946 that we actually got a picture of our planet. I mean, as far as we know, this has never happened before in all of human history. And so I just think it is really, really cool that this was the first time in humanity that we ever managed to conquer Earth's gravity. And when you study astronomy, you learn that Earth is not the most massive thing. It's actually a fairly small little rock, all things considered. But the gravity of our planet is immense for us, little tiny, tiny, tiny humans on its surface. And it is very, very hard for us to do anything that gets out to escape velocity, that will actually be able to escape out of the gravity well and not come crashing back to Earth. Now, this was early times, and there were early rocket experiments going on out in White Sands, New Mexico in particular, parts of the deserts in the US, around California as well. Really kind of not very safe, but revolutionary rocketry tests. And these were the first, what we call the first of the real modern rockets, the first ones that could get out of, well, our gravity. Now, this was 1946, which, as I say, it seems like it's not that long ago, but it was before I was born. So, and this was the White Sands Missile Range in New Mexico in the US. And the rocket they used was a modified V2 rocket because, as I say, it was very, very experimental times. There were a lot of radical designs being attempted. And this was a group of soldiers and scientists in the New Mexico desert, and they were launching this modified experiment, basically, of a V2 rocket, and it was carrying a camera. Now, if you have a camera on your phone right now, you might be thinking, oh, a camera. No, no, no. This was a 35 millimeter motion picture camera from the 1940s. So this was a very, very different device than what you're thinking of if you're looking at your phone thinking camera. And it got up to a height of 65 miles or 105 kilometers above Earth's surface. NASA defines the edge of space as 50 miles or 80 kilometers above the surface. And after a few minutes, the camera dropped back to Earth and was destroyed, as you would from falling from that height. But the film survived, and this is really, really cool. Now, of course, the newspapers of the day were very excited about this, and these early images from space were exciting to science fiction and science fans alike. So the Air and Space magazine famously came out with a full story, which I encourage everyone to read, but I'll just tell you the first little part of it. So this camera, which was destroyed after it came crashing back to Earth, the film was protected in a steel cassette. And this is the same type of cassette that you might have seen if you've ever seen old movie film cassettes, where they would have those big cassettes and the movie film would wind up in it. It was that kind of cassette. And it actually came out with pictures. So you can see this picture now. It's up a whole bunch of different places. It's even on Wikimedia Commons and NASA. But the recovery team had to chase down and retrieve the film from these early V2 shots, and it was actually a 19-year-old just enlisted soldier, Fred Ruley, who was assigned to the recovery team, and he was driving around the desert back in the 1940s. So this is not like what we saw recently with the Bennu, where we're all live streaming it on the internet, and we could have instantly watching what was happening, and they could see exactly where it landed and follow it down, and they jumped into helicopters and got it right away. That's what happened with Bennu. Well, in 1946, it was just this poor 19-year-old fellow with a car in the desert trying to drive around and find this thing that had fallen from space, which I just think is awesome. And he found it, and they found it in good shape, and they were jumping up and down, super, super happy, as you would be, rightfully so. And finally, they went and they got the film back. They projected the photos onto the screen, and all the scientists in the room just went completely nuts. And the actual quote is from this 19-year-old, the scientists just went nuts. That is the official quote. as would be expected, I suppose. Very, very exciting. So before 1946, the highest pictures ever taken of Earth's surface were from an Explorer 2 balloon, and the balloon had gotten 13.7 miles in 1935, which was high enough to see the curvature of Earth. So this wasn't the first time that we ever saw the curvature of Earth, but it was the first time we ever actually got a picture from bona fide space. The V2 cameras reached more than 5 times the altitude, and they could clearly show that planet, our round planet, shone against the blackness of space. And because this was a 35 millimeter film camera, when the frames were stitched together, you could actually show how a little film basically. And another great quote, the engineer who developed the camera wrote in National Geographic in 1950 that these photos would show how our Earth would look to visitors from another planet coming in on a spaceship, which is just really, really cool. And of course, this was only the start. Scientists quickly got better at taking Earth's picture. About 6 months later, there was V2 number 21. So they went through a lot of rockets on these tests in 1947, so about a year later, from 162 kilometers up, which is much clearer. You can see clouds and the features of the Gulf of California. The first picture is very, very grainy. You can see the backdrop of space, but you can almost feel the pixels on that one. So I definitely recommend everyone to go and look at these pictures and enjoy. And the fun thing I thought that would lead this to start with this article from 1946 is not only this is the start of the rocketry that got us out into space so that we can explore all kinds of things, including Bennu, as I mentioned before, and asteroids and comets and other planets, and all sorts of great stuff. So this is a little shout out to back in 1946 and the early black and white photography. And there is an old Universal newsreel about the launch, which of course I can't show you because this is not video, but I recommend for everyone as well. So, so Mary Helen, did you ever get to see the old 1946 picture from space?
No, although I may have seen it and I don't, and it wasn't really clear where it was from, but I don't remember it off the
It's
top
a
of my
very
head.
grainy picture. It's basically like the top one, well, the side corner 1/3 is all black, and then the rest is just a very grainy, sort of pixelated, um, well, not pixelated, but grainy, film grainy, I should say. It's grainy and low resolution film of the atmosphere, and you can just see that like there's clouds. It actually it actually barely looks like a planet. They, as I say, they soon got better.
I don't think I've seen that one. I guess for me, the one first, although it didn't happen around this time, the one first that I always think of is the first images of Mars from the Mariner
Oh
mission.
yeah, similar quality.
Yeah,
Yep.
it translated back 22 pictures in like 1965, and people just went, it's like you said, kind of went crazy.
Yeah. Well, best described as the 19-year-old said, the scientists just went nuts. Like, yep, that sounds about right. But yeah, it's a really fun little moment in history. Of course, this is the V2 research program of the late 1940s was based with the American military, and they actually had dozens of captured German missiles. For probably obvious reasons, but they kept them, brought them to White Sands in 300 railroad cars at the end of the war, and they used the V2s to refine their own rocket designs and get better at launching things into space. And basically, the army was like, okay, we're going to take all these missiles, and they took them. I mean, I don't know, but they basically just took them to White Sands, and then said, okay, scientists, you can put in however many instruments you can get into the nose cone, and we're going to set it on fire. And they just started launching these things, and so it was yeah, crazy time in history for rocketry. And basically between 1946 and 50, as far as I know, they got over 1,000 Earth pictures eventually, and they got up to as high as 100 miles. And yeah, a couple very lucky young folks actually got to participate as well. I don't know how young our crew feels the age of 19 is, but some 18 and 19-year-olds who had recently joined up with the US military got to play a large part in the rockets and the whole development. So it's pretty fun and interesting, I suppose.
Yes, one of those sort of moments in technology where suddenly space flight became possible.
Yeah, well, and it was having good rockets and then getting or well, taking and keeping a large supply of even better rockets, and then using that to make even better rockets, and iterating that design technology with what you already had to improve to the point where space became possible. So it is a yeah, that sort of very dynamic moment in history for rocketry in particular. All right, so that's rockets, but let's get into rocks. Actually, so once we're in space, what can we do? This gets us to the second This Week in Space and Astronomy history that I wanted to go to, so a little bit more recent, also on the 24th of October in 1998. So this is quite a bit later, so 1946 to 1998, they had a long time to perfect their rocket launching techniques. And by 1998, all kinds of things had been launched, many of which we have talked about on this show before. But this one in particular was Deep Space One, which I like because I'm a Deep Space Nine fan, but also because it was the launch for a comet and asteroid mission. So it's Deep Space One, or DS1. And this Comet and Asteroid mission was basically a NASA technology demonstration spacecraft. And so it was basically trying to show off what could we do with this craft, can we get by? And they tried to do a flyby of an asteroid and a comet. It was part of a whole new program called the New Millennium Program. They were trying to test advanced technologies, and it was launched, I say tomorrow, but in 1998. And it did actually carry out flybys of asteroid 9969 Braille, which was its primary science target. And then it went on to go ahead and get an encounter with Comet 19P Borrelli and do some engineering testing, basically. It did have some problems with its initial stages and its star tracker, so it had to repeatedly make changes in its configuration. And the flyby of the asteroid was basically only a partial success, but the comet encounter retrieved very, very valuable information. So this was a different kind of cutting edge mission, I suppose, and getting us out to some of the things in space that we really were not exploring very well because asteroids and comets are small, hard to get to, and we just didn't have that many spacecraft out there. So this Deep Space One technology was partly testing whether or not it could do solar electric propulsion, solar concentrator arrays, ion and electron spectroscopy. It had a deep space transponder. It had all kinds of technology to validate for future missions. It had low power electronics, autonomous, I should say, autonomous, autonomous navigation, power actuation and switching. Low power electronics were key in this because, of course, if you're getting solar power, even back in 1998, you weren't getting a ton of power, so you needed to have electronics that were very, very efficient. And we've talked about how important solar power has been for spacecraft development. Once it was launched, it actually did quite well. And this was, if you're curious, this was actually launched on a Delta rocket, which is quite a bit of an upgrade from our previous story. The Delta II was an expendable launch system that was actually designed and built by a company, McDonnell Douglas, and it was part of this Delta rocket family that entered service in 1989. So basically a shiny new rocket type. And they had light and heavy different rockets, and they had basically a record where they had earned 100 successful missions in a row, which if you knew how many rockets they had launched in White Sands, you would be really, really impressed. So there was a lot of rocket explosions in early rocketry, and this was pretty cool because they had 100 successful missions in a row with the Delta II. The Deep Space One was obviously successful, and it did launch as it should. It had all kinds of fun things being tested, and of course, the asteroid 9969 Braille. It's also called 1992 KD if you're an asteroid searcher. It was actually just on the innermost region of the asteroid belt, so sort of going out from Earth a little bit. And this asteroid belt region gets you not too far from Mars. 9969 Braille. I should just call it Braille for easy. It was classified as a Mars crosser, so it crosses Mars's orbit, and it rotates fairly slowly. So it was photographed by Deep Space One, but unfortunately, this is where one of the malfunctions happened. So if you go to look up the image for this asteroid, it's very, very blurry. They have done what they can to clean it up, but it's extremely blurry, obviously not circular. But more than that, you can't say too much within believability about the shape of it. It's thought to be about 7.8 times 10 to the 12 kilograms, and it's so not a particularly large asteroid as all things go. About one kilometer by maybe 2 kilometers by something like 1.6 kilometers. So, very, very hard to say what the exact dimensions are as well. So the asteroid, fortunately, they did get a picture, just not a great picture. The the asteroid people have tried to follow it up a little bit, but to my knowledge, no one has yet gotten a better picture of that particular asteroid. So it's this way I say qualified success. The comet, Borelli's comet, or 19P Borelli, is a periodic comet, and it actually last came to perihelion last year. Yes, this is 2023, so that would have been February 1st, 2022 was last year. So this comet is basically about 0.4 AU from Earth on its closest approach. So that 1 AU is the distance from the Earth to the Sun, so a little less than half. And the comet also has its best image from Deep Space One. And in this case, they were actually able to get images of the comet's nucleus from about 3,400 kilometers away at 45 meters per pixel. So at the time, this was the highest resolution ever seen of a comet, which seems crazy given the amazing pictures we have now from spacecrafts that have landed on comets. But this was only 1998, and this was at the time, the highest resolution. And they did actually try to keep the Deep Space series going, but they only got up to Deep Space 2 before they stopped with the Deep Space series, unfortunately. So we never did get up to Deep Space 9 in NASA, only in science fiction. Anyways, very fun mission, and a little bit of our investigations into asteroids and comets getting started here. And of course, with the asteroid and with the Braille asteroid and the Borelli comet, both of those are fairly low density objects, which is something we're going to talk about a little bit later as well.
Yeah, I always found the DS1 fascinating for the propulsion system because it was the first time they started using the ion engines, which was something other than a chemical engine. And I guess the big difference with the ion engines is they don't accelerate very fast, but you can keep accelerating for a long time.
Yeah, exactly. And that was one of the they do talk about science fiction and science crossovers, because of course ion engines had been an idea for a long, long time, but because they weren't as powerful, it was very hard to get them to work. But if your spacecraft is very light and your solar panels are very light, then you don't actually need a lot of thrust to get yourself places in space, because there's no gravity. And this one you're absolutely right. It was a very, very cool, adaptation on the ion engines, because they'd had ion engines before, but they weren't able to get the what's called impulse, or basically kind of thrust, pounds of force to push the spacecraft around as they would like to have. And this was an electrostatic ion thruster.
Yeah. So it's like I said, when you talk about the science fiction, of course, all the rockets we're familiar with are chemical ones, and yet this was the first one that wasn't chemical. So in some ways, technologically, that was a fascinating sort of turning point for space exploration. I mean, they've tried solar sails since with some limited success. So
Yeah.
I guess that's where I think the DS1 for me really sort of fit into, sort of history of space travel, just because of the uniqueness of the propulsion system. And it was reasonably successful at what it did. right? It just, you can't expect them to move very quickly at first.
Well, and then one of the key things is as we have been going forward in technology, things like computers, computing components, cameras, electrical components, all of the things you need to make a spacecraft do science have all been able to get very, very, very much smaller and much lighter. And that means, basically, if you launch the equivalent of your cell phone with some protection around it and some solar sails, you could do some science in space. And the smaller that you make it, the less you need chemical propulsion. And solar sails in particular, I think, have been shown to be potentially very, very efficient on something like really micro-sized, simple little satellites. And there's of course some interesting proposals to use lasers to accelerate extremely small satellites. Was it light sail? I think it's called.
Yeah.
Yeah. Um, Light Sail 1 and Light Sail 2 are the Planetary Society proposals, but very, 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 very small little satellites, big light sails on them, and laser beams could then shine onto that to accelerate the craft once they were in orbit, and they would be able to go, I mean, not the speed of light, but maybe a small fraction of the speed of light, and within some number of human scales of years, maybe a few hundred, actually get somewheres. So
Yeah.
it's getting interesting with ion propulsion and with solar sails, and like very small things like studying comets and asteroids. You often don't need a large spacecraft to get there. Just a small camera that's going to take very, very good pictures would be enough in some cases, unless you need a sample return.
Yeah, that's a whole different level of technology. But I guess the thing about the ion and the solar sails is, as long as they have sun hitting them, or the electrical power source for the ion, it'll keep accelerating. The thing about chemical rockets, you get a big boost and then you coast the rest of the way.
Yeah, exactly. Well, that's running out of fuel is the problem for everything, because of course once you get out even just to Jupiter, the sun's intensity goes down.
Yeah.
So yeah, if you want to keep accelerating, you do have an ongoing problem in space travel. But at some point, usually you have to try to slow down to take pictures of whatever it is you're out there to see,
Yeah.
which is a whole different problem.
Actually, you mentioned running out of power, and I was reading an article last a day or two where they're talking about the Voyagers.
Yes.
By being launched in the 70s, they're still running, but they're now thinking they may actually run out of power to run these things in the next 5 or 6 years, which is, if you think about how long ago they were launched, it's pretty spectacular that they've lasted this long. But even they're reaching the end of their capability to generate enough electricity to keep functioning. So
Yeah, well, and they were sort of launched in between the two programs that I mentioned. They were launched in 1977. And that was, of course, they're taking advantage of a favorable alignment of Jupiter and Saturn and Uranus and Neptune, so that they could kind of get pictures of those planets as they were going past. But 1977, again, either very long ago or really not that far, depending on how you think about it. But these things have been flying through space, and communicating back to Earth basically since then. I mean, with a few minor hiccups, of course. But yeah, the system is absolutely awesome, but they are running out of power.
yeah.
And eventually, it was sort of a question: are they going to run out of power? Is something going to fail on them, or will we just the signal becomes so weak that we cannot communicate with them anymore. So Voyager 1, last I heard, is still going to go until 2025, and that's when they think that its generators, basically, it's got a special kind of radioisotope thermoelectric generator, will no longer supply enough electric power to operate its science instruments. And at the distance, and I'd have to check, there's a little website that says exactly
where it is.
how far it's gone to this date. But it's something like gosh, what was it? I had it just a second ago. So it's been going 46 years approximately. And its distance is 161.5 AU from the sun, and 162 AU from Earth because of the angle. So if the Earth-Sun distance is 1 AU, this is 162 times farther away from us than the sun is.
I mean,
So
and just to put it in perspective for the solar system, I mean, Pluto at its aphelion is around 50 AU, so it's more than 3 times farther away than Pluto at its furthest. I mean, it's way out.
Yeah, it went past Pluto a while ago, and the solar system is huge, and of course it's found things that no one has expected out there. And the fact that it's in operation beyond the outer boundary of the heliosphere, which is the sort of outermost atmospheric layer of the sun. So it's sort of basically where basically the bubble of the heliosphere is kind of pushing back against the interstellar medium, as I understand it.
Yeah.
Now, of course, these little crafts are surviving out there. So if we did have ambitions of going out of our own solar system, at least we know we could get there. Because if these little guys could make it, so could a larger ship, I suppose. But the power is a real question, because at that distance, the amount of energy you're going to get from the sun is going to be negligible. I mean, it will take you decades to fill up your solar panels.
Yeah, you're looking at some other form of energy. It's actually interesting. If you look, JPL still has a mission status page.
Yes, they do.
So, and it's when you think about how long it just takes a signal to get back. I mean, you're looking at
18 hours.
18 hours for Voyager 2 and 22 for Voyager 1. It's just like, God, they're so far out right now.
Yeah, and that's, I mean, and as the signal travels, remember, these signals spread out as they travel, so it gets weaker and weaker and weaker and weaker. And that was one of the big worries, is would we be able to keep talking to them? But yeah, this is the NASA's longest lived mission, and it has gone way beyond what anyone thought. But still, it has a lifetime. Like, these kinds of missions, they can't keep going forever, because they will run out of fuel. And that's something to think about if you did want a mission that maybe you wanted to have a spacecraft that could run for 100 years. You'd have to think of something else. Anywho, we got a little bit off of our comet. So comets are out there in the Voyager region, the long period comets, I suppose. And of course, the icy outer part of the solar system being woefully underexplored is something that we've been trying to address recently with some of our missions. Now let's go ahead, and I'm just going to do a quick reminder for everyone. So this is about the middle point of the show, and it's a time for me to do a short reminder to all of our listeners that you are listening to York Universe, broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. If you would like to see any of our archive shows, or sign up for tours and chat, and of course send us emails. You can always see our website at yorku.ca/science/observatory. Right now we're on Twitter at York Universe and Yorku Observatory. And tonight you are listening to Professor Mary Helen Armour and Dr. Elena Hyde discussing, we're getting on the way to discussing asteroids and rockets and things and comets and icy outer solar system stuff. So this is a reminder, this is part of our online public viewing. It is too cloudy to open the telescopes in Toronto right now. So our crew is showing you some really, really lovely archive images that were taken not that long ago through our wonderful telescopes here on campus. So swing on by if you're not already there and join in the YouTube chat. All right, so let's get on to our main items. So I do have a short reminder for everybody. I mentioned that we have tours at the Allan and Carswell Observatory. I would be very remiss if I did not, at least at some point, remind everyone that we are doing a double tour happening this Wednesday. We're having a wonderful in-observatory tour. If it's cloudy, we obviously won't be able to open the observatory, but the tour can still go ahead. So Wednesday tickets are now on the website, and coming soon are tickets for next week, which is actually going to be on the Tuesday, not the Wednesday, because it's a special Halloween tour. So we're doing what we're calling Haunted Hydrogen Halloween at the Allan I. Carswell Observatory. You can come along and learn some spooky facts about hydrogen, or just look at the Ghost Nebula and see a wonderful decorated telescope. Those tickets will be up shortly on the website as well, free as always, but please do get your tickets online so that we know when to expect you. And very much looking forward to putting up some decorations, and nothing too scary, of course. Nice lights in the telescope, and maybe we'll have some candy for kids on their way out. So that means, of course, next week there will be no Wednesday tour, but a Tuesday instead. And this week, this coming October 25th, there will be a regular tour. All right, so that's all of the updates that I have for the show today. Now we have some really interesting news items that have been happening in all kinds of fun rocky areas. Of course, we've also been talking about Bennu all the time, but it would be very remiss of us not to also talk about Psyche. So Psyche is a NASA space mission that launched a little bit ago, so October 13th, 2023. So this year, we're back in current news now. And it's basically looking at exploring the origin of planetary cores, because they think the metallic asteroid 16 Psyche might actually be one. And Mary Helen, I know you have some thoughts on this object.
Yeah, I mean, Psyche's a fairly large asteroid. It was discovered quite a while ago, back in the 1850s. So it was one of the early ones discovered. That's what the 16 is attached to the name means. If you see an asteroid, you see the number in front of it, that means sort of what number asteroid it was. And Psyche is 16, so it was a fairly early one. I mean, it's over 200 kilometers across at its widest. And the fascinating thing about it is they think this one is a large part metal core. And that, as you said, Elena, seems to imply that it's probably part of originally of a larger body that got smashed apart. And what you're looking at is the core. If you remember, Earth's core is mostly metal, it's iron, nickel, and they think Psyche may have been originally the core or part of the core of a planetesimal during the formation of the solar system. It's kind of a neat mission too, because most of the ones we've seen, whether you're talking about something like Bennu or some of the other sort of asteroids and comets they've looked at, are less dense objects. But Psyche is one of those rare metal asteroids. So this is kind of a first that you're trying to go and look at something that's not a rocky body and not a gaseous body. It's sort of at the total other end of the spectrum from, say, a comet, which is fairly diffuse and not very dense. This is quite a dense object. So it's kind of an interesting mission.
Yeah, and it having these other kinds of objects. It's we, as you say, we've seen Bennu, and not too long ago we also saw the DART redirection test for the asteroids Didymos Diformos, which is a binary asteroid pair. But those were things that when you hit them or impacted them, they kind of flew apart. They were very loose. And we saw that both times really, really well now in these recent missions. But if you hit Psyche, it would probably not fly apart. It's very dense. And what we do know about it is we can tell it has very high density, and it must be made, they think, something iron and nickel, maybe something else, maybe rock, sulfur, carbon based. And there's all kinds of cool ideas about how it could have formed, whether or not it maybe was part of early solar system formation and formed near the sun so that it was reduced to metal over time as lighter elements were stripped away from iron atoms. There's been hypotheses made for how things could have formed in rocky ways in the early solar system. So maybe this is one of those. Would it have, little, what kind of features might it have? Would it have, little metal spikes and spires, and would there be sand? Would it have volcanic reactions? Would it have sulfur content? And we do know there are craters, but there's just people's imaginations are just going absolutely wild. I saw one article that was imagining some sort of metallic spires and spikes forming naturally, and I would love to see that, but we're not there yet.
I mean, and it's even, like for someone who does sort of impact crater, the thought of what would a crater look on a body like this, because when you have cratering on Earth, it's impacting into sort of surface rock that's just not that dense. So what happens when you impact into metal? It's got to be sort of a totally different kind of structure. I don't know, like the pictures they have are not going to be detailed enough at this point to really tell you. So it's sort of like even just getting close and being able to take high resolution images of this,
Yeah.
still days or weeks away, is just going to be fascinating as to what it'll show us.
Yeah, and I do actually have to give a special shout out as well to the rocket that launched the spacecraft, because we did start off talking about rockets, and I just want to give honorable mention to the Falcon Heavy rocket, because the Falcon Heavy is what launched Psyche. And this is, probably, we're talking about steps up in rocket revolution. This is now one of the real workhorses for launching things into space. So, we hope it will be a real workhorse for launching things into space. And of course, once it's in space, it still takes several months for scientists to go through checks of the spacecraft and its instruments. It actually does have some pretty interesting thrusters as well, because doesn't it also have ion? Yeah. Hall effect thrusters. So it's also got this, again, and that's something that came from this Deep Space One, test mission, evolved from there, I should say. But it's also got solar electric propulsion system, but now it's powered by what's called Hall effect thrusters, which are more efficient and also use solar arrays, but they use then electricity on xenon gas to ionize it and accelerate it through an electric field, which is pretty high-tech stuff.
Oh yeah, I mean it's the solar panels are also a large part of what are going to power.
Yes,
like you said, the amount of power that these things need now is it's tiny compared to older missions, because you've gotten so efficient with sort of the power. output.
Yeah, the lightness of the craft. I mean, it's a large craft. This is not a tiny this is not such a tiny object as we've seen. This is not going to be a one of these little pocket pocket spacecraft, but it can still be powered with solar power, which is awesome. And I think it's still estimated to arrive at Mars in 2026, and then from there, slingshot to Psyche. So we do have a little bit of a wait before.
That is the one downside of the ion engines, is they are much slower to get started. They can just accelerate for longer periods. So in the end, it doesn't take them any longer to get there maybe than a chemical rocket. And the thing is, if you're flying under power, the advantage is you can steer a heck of a lot better than if you sort of push off with a rocket and now you're drifting.
Yeah, absolutely. And this mission is one to keep an eye on for sure. I mean, obviously, slingshotting past Mars in 2026, it will probably arrive at the asteroid in what they're estimating now is about July of 2029, and then map the asteroid surface, at which point everyone's going to get very, very excited because that's what scientists do when they see pictures for the first time. Find out whether it's truly a metal core and put some facts to all of our speculation. And then it's going to use a whole bunch of different orbits around the asteroid. And it's actually going to be able to transmit data as soon as it spots the asteroid. And it's got with it, we talked about bringing technology along for a test. One of the ongoing problems with spacecraft is maintaining communications with your spacecraft. And this Psyche mission has the Deep Space Optical Communications Technology Demonstration, which is a long mouthful, but it's actually there to help test high bandwidth laser communications, testing, receiving, and sending of data to and from Earth using a near infrared laser. So it not only has a very, very high tech propulsion system, it also has a testing communications technology, which would basically be able to send data 10 to 100 times faster than radio wave systems. So if it's successful, this would probably be the next step in communicating with humans on Mars, which might also be happening in 2029. I don't know, but one can hope. So it's a really fun, really fun mission, and lots of tie-ins, not just with asteroids, of course, but all kinds of fun technology.
Yeah, I mean, it's fascinating because whether you're talking radio waves or the near infrared, it all travels at the speed of light. But depending on the wavelength of light you're using, you can send different amounts of data in sort of one package that's traveling at that speed. So it's sort of the data density versus
Yes, exactly.
That's going
exactly.
on. I mean, it's like I guess for most people it'd be like the difference between 3G, 4G, 5G. They're all traveling at the same speed, but the amount of data you can transfer in a package is just drastically different. So
yeah. Well, if you go out far enough, you might even be using ham radio or something. Anything that uses light is going to be going light speed. But again, as you say, it's very much worth noting the amount of data that you can get is wildly different. So let's go ahead and just make a quick comparison to 16 Psyche. As I say, a lot of unknowns about this one because we're not there yet, but it's really exciting. And as something we've talked about Bennu, we've talked about DART, but what some of you might not have known is that very recently, let me see, about yesterday, I think. Let me see. It was asteroid 2023 TK15. Actually, October 20th, so 3 days ago, Friday, October 20th, 2023, had its closest approach to Earth. It passed Earth at an extremely close distance of 379,000 kilometers, which sounds really far away if you were listening closely about that space distance I talked about before. But that's actually closer than the moon. So the moon is 384,000 kilometers approximately, and it was one of the closest asteroid approaches of the year. So we do get these a lot, and this is probably one of the most common types of asteroids. This asteroid is part of the Apollo group, which is near-Earth asteroids, Earth-crossing rocks, with semi-major axes larger than Earth. So they're nearby basically, and they have a chance of flying around next to us. This one went closer to the moon, and they're all named after a massive Apollo asteroid, 1862, which was discovered in the 1930s. So NASA and many agencies have been tracking these asteroids for a long time because we do want to know if we're likely to get hit. But this one just flew right on past, and very little note was made. There has not been an image made that I could find, but the NASA estimates that it was about 130 feet wide, so about the size of an aircraft, but not huge, not anywhere near the size of 16 Psyche. And it was basically, the description was a non-threatening close approach to the planet. Asteroid of average density flew by. And so I thought this would make a fun little contrast. Not super dense, not super light, and didn't hit us. So yay. So this was just a couple days ago. Blink and you'll miss it. It's already gone. Asteroid 2023 TK15.
Yeah. I mean, and this one isn't really in the size range where it would probably do, I mean, at 130 feet, so you're talking 35, 40 meters, this probably would not do much damage, if any, at the surface. This is probably similar in size if you remember back a few years ago when they had those massive fireballs in Russia that shattered windows, and a lot of people caught it on camera, and they found pieces that hit a frozen lake. This is probably comparable in size to that one. So if something this size actually hit Earth's atmosphere, you get fireballs, you might get, it's like I said, sort of air bursts near the surface and sonic blasts or whatever, but you wouldn't really create a crater or create large.
Yeah, and that is the Chelyabinsk meteor from 2013.
Yeah.
Definitely worth looking up because it was captured on so many dash cams.
Oh yeah.
So many dash cams, and it, as you say, nobody was killed, nobody was hurt. A bunch of windows got broken. It hit a lake.
Yeah.
And that's, usually for that size, it's again, it's not really very dangerous, but it is good that we can find these things and we know where they are. Just in case they do decide to hit us, or there is one that's big enough that we want to try to do something about it.
Yeah. So it's like I said, it's fascinating to think about it. They can track something that small.
Yes.
I mean, you're talking something maybe a maximum size of 50 meters from close to 400,000 kilometers away. So if you think about the relative distance and size, it's pretty spectacular they can spot something that small in the vastness of space.
Yeah, and that's something that we have gotten better with a lot of the big survey telescopes. So if you've ever wondered why astronomers are such fans of surveys, because you get so much data, and with modern computing, we can analyze vast amounts of data that just never, ever, ever would have been possible before. Beyond human capacity to analyze, but machines can do it, and we can code up clever algorithms to look for things that are different than what was there before. And we have things like the NEO-WISE and the Atacama millimeter array and pan-stars and many, many, many more. Catalina Sky Survey. All these things are amazing at helping us discover and track asteroids. That said, it's always fun to give it a try and just see if you can find any, which is there's actually some volunteer things, so you can volunteer to sign up with. I think a few agencies. I'm not sure if RASC does it, but a few places do allow amateurs to actually sign up with their telescope and help search.
That's how a lot of comets are originally found. I mean,
Yep.
a large number of comets are actually found by amateurs, not by professional astronomers, because they're just people searching the sky and happen to be looking at the right place at the right moment. And that's why so many comets have names that like you've never heard of before and never will again, because the name of the comet is usually the name of the discoverer.
Well, and that's, there's a few obvious exceptions, of course. Shoemaker Levy 9, David Levy is a absolutely famous Canadian amateur astronomer who has found a lot of awesome things, but he notably co-discovered the very famous comet Shoemaker Levy 9 in 1993 that collided with Jupiter and was spectacular. But yes, I believe he's found over 23 comets as an amateur. Amazing stuff. So yes, lots of fun things to to get involved in all over the place, if you want to. All right, so let's go ahead and finish off our final thoughts with the asteroids. I think it's very exciting to say that Psyche is out there. Cannot wait for this craft to turn on and start telling us things. And of course, with this experimental system, you kind of get a double bonus. But it is also nice to know that for the more practical term, we are able to also find the small little asteroids that do pass quite close by to Earth.
Yeah, I mean, we've kind of wandered a little all over, but sort of a lot of different solar system stuff.
Oh yeah, and that's how you go in astronomy. It just keeps going and going. That's what space does. All right, so we probably should wrap up here. Any final asteroid comet thoughts from you?
It's like I said, you've picked Psyche, so I'm curious to see too where the next one is. I know Lucy's on the way to the Trojans.
Oh yes.
You're expecting first results from that one in not too long, if I'm remembering rightly. So that's another interesting one. It's like asteroids and space missions seem to be a growing thing.
Absolutely. Well, you heard it here first, folks. All right, so we should probably wrap up for tonight. Thank you, everybody. You have been listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening, of course, have been Professor Mary Helen Armour joining us once again, and myself, Dr. Elena Hyde. And thank you all for joining us this evening. And if you have any questions for looking for show notes, contact updates, anything like that, see our website at yorku.ca/science/observatory or Halloween event tickets. Thanks for tuning in. Clear skies and have a good night.